Good afternoon. Today I'm going to talk to you about the use of airborne and spaceborne imagery to map fire damage on the oak and tropical hardwood hammocks as a result of the deep fire. The project objectives were basically at first to identify all oak and tropical hardwood hammocks within the deep fire perimeter. We also wanted to determine the successional status of these hammocks and to see how the deep fire affected them. And we wanted to determine the fire damage within these forested communities. So you may ask, why oak and tropical hardwood hammocks? Well, one of the reasons we looked at these communities, because Jim came knocking on our door and said, look, you got this project, go do it. But it's really mainly because they are restricted within the range of Big Cypress. They provide crucial habitat for epiphytes, orchids, bromeliads, and ferns. And the oak mass is an important food source for panther prey. So there is a relationship between the loss of oak habitat and possibly the panther. So the deep fire, most of you in this room know more about the deep fire than I know. It basically was a lightning fire. It burned for about a month, and it covered about 28,000 acres, which is about 3%, I believe, of the actual reserve here. It occurred in a period where water levels were really low. We hadn't had a lot of rain, so it burned really hot and intensive in that area. And so it did have a lot of fire damage in these oak areas in here. So, area surveys sort of indicated that some of these communities had burned and there was a lot of oak damage. So originally the idea was to use existing maps of these communities, but we found that these existing maps didn't really have the scale necessary that we were looking at, and a lot of these communities weren't mapped. So we went back to 2009 red, green, blue area photographs that were available, and we were going to use that to make a map of these communities. One of the issues was that these photos were only red, green, blue, and so it didn't really have the spectral resolution that we wanted. So what we did was, using just those 3 bands, we calculated 6 other spectral indices that would help us differentiate these community types. Even though you could see within these photos, you could see the cypress and you could certainly see the slough. The problem was, were these the hammocks that we were interested in looking at? And were these pine forests and saw palmettos? We weren't really clear as to what we were seeing on the photos, so we needed some way of enhancing the images. So we calculated these 6 spectral indices. Panchromatic is basically, we just turned the red, green, blue into a grayscale image. The green percentage vegetation index, photosynthetic vigor ratio, plant pigment ratio, and then these 2 other spectral ratios that were sort of a playoff on these. We're not really sure what the ecological or even physiological response of plants are when you calculate these, but they seem like something we want to do to just add data and see what we come out of it. So now that we had the red, green, blue image with 3 bands, we had now these 6 extra bands. We had now a 9-band raster image. It's a tremendous amount of data. So to help reduce the dimensionality of the data to something that we can work with, and normally with GIS, you kind of, or remote sensing, you only work with 3 bands at a time because that's what you're looking at on your computer monitor or on your TV. You're using 3 guns. We use the principal component analysis to reduce the dimensionality of this data into 3 bands that we can actually work with. The results were this. So here's the original imagery. This is the principal component imagery, or the image that was created using the first 3 principal components, which explained about 98% of the variability in our data. And a couple of things that struck out to us was, you can still see the sloughs. You have these yellow or light colored areas, which seem to represent these areas really well, and then we have these striking red areas. And once I saw this, I thought, okay, this is probably the community we really want to look at. This is what's really telling us where these oak and hammocks are. And these are, in fact, tropical hardwood hammocks in here. And so we had this, and we said, okay, we got something keyed out, but we weren't 100% sure. So shortly after we did this, we went on a helicopter flight for 2 purposes. One was to validate this red color, to say, yes, those are in fact oak hammocks. And 2, we needed to create a sort of signature for these different communities that we wanted to map. So we wanted to go to individual areas and say, okay, what's this? What's this? Is this really a tropical hardwood hammock? So we created a sort of spectral library or reference. So we tried to do the supervised classification once we get back from the field, and we got this mess. You know, Cypress is sort of, we said, was this brown stuff, yellowish stuff. The oak sort of stuff was here, so it was really a mess. It just really got to the point where it's like, we really can't do anything with this supervised classification system. We were hoping that it would be done in 2 hours and, you know, we go watch football. But it didn't work out that way. One thing that we were able to do, however, using the principal component imagery, was create the outlines. And these are very good outlines of the woodland communities, the upland woodland communities. We didn't bother with the cypress. So these are all upland. So we now have a good map of these areas, at least their outlines. So using this, we decided, okay, we're going to have to hand digitize or screen digitize these communities. So after, you know, countless hours and a couple pair of glasses, we ended up with this map, which has about 6 communities, that we mapped in this undetermined community that was that had a spectral signature that we really couldn't identify at the time. And those were left for our ground truthing efforts to sort of tease out what they were. And it could have been that some of these communities might have been tropical hardwood hammocks or oak hammocks or pine forests. We didn't know. It was just really weird to decipher that. So during the last 2 weeks, last 2 to 3 weeks, we went out and did an accuracy assessment. We went out to do 117 points. That was the number of points that we really needed based on the size of the project and the number of community types. Fortunately, we were only able to do 37 sites. It just got to the point where we were having issues in the field recognizing these communities because of the fire. So we were like, okay, what is it? Well, I don't know. We can't make, you know, we couldn't decide what it was in the field because these communities had gone through so much change. If you look here, we have the producer's accuracy. So in some conditions, I did really well. Not so good here. And the user's accuracy, which is really what you're interested in. And again, some communities that did really well and other ones not so well. Overall, we have 62% accuracy on this map. It's not great, but considering the complexity of this landscape, it's not too bad. One possibility to improve this classification is to merge this oak saw palmetto hammock and this oak saw palmetto scrub together. This was really giving us an issue in the field trying to, are we looking at a scrub, or are we looking at a saw palmetto hammock that it's been burnt out, and so now we're just seeing just most of the saw palmetto. And that is really what we were keying in on the aerial photograph anyway, was the saw palmetto we were mapping. So if we group those two communities together, we can improve the accuracy of the map to 76. Now this again is based on 37 points, so it's hard to say. And then this mixed hardwood community is a community that I think we're going to play with and try to improve upon. So here's a picture of a hammock that was taken during our last survey. And you can sort of see the oaks that are burnt up, some saw palmetto in the understory, some damaged palms sticking out, and maybe some oak that survived. So the third aspect of our project was to ascertain or determine fire damage on these hammocks. And how could we do that from a remote sensing perspective? You can see here that the oaks seem to have this high reflectivity effect, whether it's an albedo effect, as we talked earlier today. So we thought, okay, maybe if we looked at Landsat imagery and looked at changes in the spectral signature of these communities. Now, we were fortunate enough to have 2 Landsat imagery that were clear, except for that cloud and that cloud shadow. We didn't have to worry about any clouds or any sort of atmospheric disturbance. The images were atmospherically corrected, and then the digital values were corrected for at-sensor reflecting. So that means you can actually go to that pixel, any one pixel, and compare it to its corresponding pixel over here and match it 1-to-1, and not have to worry about whether it's the atmosphere or it's the sun angle or it's the time of year. You know, it's a 1-to-1 comparison. Also, because it was for the same time of year, and the difference between these dates was like January 17, 2009, and like January 19, 2010. We were in the same season, same sort of environmental conditions, so we were dealing with cypress that were putting on needles or plants that were coming in to flower. We were basically basically in the same season, so it made comparison really nicely between years. So if we looked at, the first thing we thought of was the red-green reflectance. So this is what we're seeing on that signature from those oaks that are reflecting back at us, is the red, green, blue, and even near infrared and middle infrared jumping back at you. If we look at the difference between 2009 and 2010 on that imagery, we can see areas in the whites in being areas that have increased. You can see areas that have a significant increase in the red-green reflectance. If you look at the difference between 2009 and 2010 for the entire area that we mapped, that's all the communities that we mapped, we see that there's a significant increase between 2009 and 2010 in the red-green blue reflectance over time. Now, if we look at something a little bit more specific, the green percentage vegetation index, which sort of tells us is an indicator of vegetation, we see that there's also been a change in the the green percentage vegetation index, where brown areas indicate a decrease in the amount of photosynthetic material as a result of the fire. And again, we look at before and after, and what do we see? We see a significant decrease between 2009 and 2010 in the amount of green percentage vegetation index, which is what you would expect. These areas burn, there's less material there for photosynthesis to occur. The next thing we wanted to look at was the difference normalized burn ratio. This is something that has been really developed for northern latitude forests, where a fire occurs and recovery is much slower, can take up to a year or longer. Where here we know that you have a fire within 2 weeks, a lot of areas have come back, especially the herbaceous vegetation of the palm. So we attempted to use this knowing that we may have a problem with it, but hoping that it would work. And it's basically no different than NDVI, for those of you who are familiar with NDVI, except instead of using red and near infrared, we use near infrared and minus the middle infrared. So that's for time 1. If you do that for time 2, you multiply it times 1,000 to turn it from a decimal into an integer, which is a lot easier to store in imagery. It takes up less space, and it's a lot easier to interpret than having to deal with 0.678. You're dealing now with 660 or something. And you end up with values within this range. Now these again have been developed for northern latitudes. Their applicability to South Florida is yet to be determined, but the idea was that, well, let's see what we get and see if it works for our communities. I think what we're doing. So here's the result of our difference normalized burn ratio on these forests. And so if you look again, we have these areas with very high values of BMVR. And so we have these low to moderate to high areas where the fire seems to have been the most intensive. If we focus on this particular cell there, we can see the pre-fire image, 2009, red, green, blue, nice full canopies, no openings, everything looks to be really nice. Here's the DMVR. And then this is the post-fire image, 2010, about 4 or 5 months after the fire. So you can see this area in here, where you have this high reflectance, sort of matches this area of high, sort of moderate to low fire intensity. The same down in here, you see these areas in here that show where the fire seems to have been the hottest, and then areas in here where it didn't burn as much. Well, in here you're getting the greens. There's some green, getting a little bit of green there, and up in this polygon did not burn that much. So basically, what we've done with this project is we've gone ahead and mapped these communities. We now have a map of these oak hammocks and tropical hardwood hammocks within the deep fire, and we've been able at least to show that we have some spectral indices that we can use to monitor the effects of fire over a year and potentially over multiple years. And it's something that land managers here could use and fire managers when you're burning to see how your forests are recovering after a fire.
About 6 years ago, I decided I wanted to study bats in South Florida and see if there was any relationship between their activity and various environmental factors like weather, temperature, wind, and moon-faced. I started this study and got all kind of recordings and all kind of data, and then I very quickly realized I didn't have any good reference files to decide what bat was doing what. So we had to back up and go get those files. Fortunately, about the time I started trying to collect the files on my own, Kathleen Smith started her study in the Picayune Strand as part of the restoration project and was catching a lot more bats. And that made it possible to do this study. So we subsequently were working together to get a collection of reference files that we both can use to analyze all of our data. I'm sure all of you know bats are difficult to see. They're kind of hard to identify because it's usually at night. But they make a lot of noise. Most of it we can't hear, but it is pretty easy to record if you have the right equipment. Is it a straight one? Not working. No sound? There we go. So you get a lot of bats and you get a lot of noise, but it's kind of hard to do anything with that. Other sound for the next one too. The idea for this study, you guys hear that, you know what that is, without me showing you this. So we could do the same thing with bats, and we have a way to identify them. Well, the first thing we learned about catching bats in Florida is you need a really tall net. For about a year, I tried with a single net, and if you have a single net, it comes up to about here, and I didn't catch anything. So when Kathleen started her study, we decided to try the triple high nets. You get these nets up about 21 feet in the air, and your capture rate goes way up. Still not like it would be in other parts of the country, but much better around here. Well, part of her studies document the bats that are living in Picayune Strand, and thus the bats that are probably living in Big Cypress in this whole area. And she's getting various parameters measured on them, and, so we can see how they do with the restoration of Picayune and have some idea of how that affects them. Also doing some genetic analysis on them. There's still some question about species differentiation between some of them. When Kathleen gets done with her part, I get to do my part. This is a little free-tail bat she's about to release, and as she's getting ready to release it, we set up a recording device. If we have enough people to help, we'll set up more than one because you never know which way the bat's going. And you can better quality recordings with more devices. Bats make a lot of different sounds, and most of the sounds we're not capable of using to distinguish them. The first group of sounds that, for our benefit, we call roost, chatter, or social calls, are hodgepodge noise that just about any bat can make. This is the bat that Kathleen's holding in her hand, and in reality, this is probably bat profanity. But he wasn't real happy. Here he's getting a little bit closer to being ready to take off and fly, and he goes into what we call a clutter call, and you can see this is much different from what he was doing when he was cussing us out over here. The clutter calls they often do when they're in a confined space and they need rapid information back, and so they switch to that pattern. Again, the clutter calls are not very useful in distinguishing one bat from another. What we're looking for is a church call. Again, this is that same free-tailed bat. This is a whole sequence of calls, and the software puts them all together. There actually more time space between them. But you can then pick out one of these calls, and you can take that one, and you can analyze that call. And you can't really read the numbers down here, but it's come up with all the parameters of where it starts, where it stops, how long it is, all those kind of things, so you have something to compare. The Brazilian free-tailed bats are one of the bats that have been studied the most with acoustic studies. And we have a lot of really good data. This is like the perfect call for one. And this kind of data is what we're hoping to get for all the other bats that live down here. But you notice there's a little uptick on the beginning here. You only almost, at least with our bats, only Brazilian free-tails do that. The software doesn't give you an absolute volume level, but it gives you a relative volume level. So the loudest part of the call is in red. Again, another characteristic of Brazilian free-tails is they often start their call at the loudest volume and then work their way down. And then they very often, if you get a good quality call, you'll see this will trail off at the end. So between the values and the shape of the call, it's pretty easy to identify that bat if you get a good quality call. Our other bats down here, this is our bonded bats, probably the most endangered one we have. There may only be a few hundred of these left. Are pretty easy on us. There's nothing else down here that's this low down. They're typically 12 to 15 kilohertz range. So they're easy to identify. You don't have to worry about their call too much. Many people can actually hear them call. It's down in the range of just hearing younger people, particularly female. If we start working our way up the frequency levels to our other bats, get to the yellow bat, you see his call is pretty similar to that free-tail bat I just showed you, at least this part of his call. So you only get part of his call if for some reason it's far enough away you don't record this first part. They start to overlap. So the idea of our study is to try to get enough data on each species that there's some way, if I just get the middle part of his call, I can distinguish it from the other bats. Again, going up, you get the big brown bat. He's again the same range, maybe just a little bit higher. The evening bat, very common bat down here, usually up higher than the others, but not always. Seminole bat, again, just a few kilohertz higher than the others. And the tricolored bat, usually higher than all of them, but not always. So, we haven't gotten all our data yet. We've got about 30 more nights of work to do this fall. And then once we get all of that in, we'll try to analyze them. Some of the things we'd like to look at is we'd like to analyze them by species and by their sex. Do the females say something different than the males, or are they at a different frequency? Nobody's answered that. The thing that got us started, we wanted reference libraries so that we can compare calls out in the field to see whether we can identify them. And we've also had a lot of interest from other bat researchers who would like to compare these calls to calls, say, of the same species but living somewhere else. And there's been some concern that the bats in Georgia have a different accent than the bats in Florida. And that's it. Let's see if questions.
Well, those 6 species that you showed, those are the 6 species that are extant in South Florida?
Correct.
Or are there more?
Those are the only ones we've caught. The very first bat I showed you on the opening slide, the Coriolanus, the guy with really big ears, the book said he should be here, but we've never caught him. So my guess is he isn't here, but that's the book's still showing. The other, there are some bats coming up from the Keys that we may get eventually, but we don't have. Okay. Jim had asked us to talk about trail cameras, and I could talk about photography and cameras all day, but I thought you'd probably be more interested in learning about panthers in relation to trail cameras. Be a bit more interesting. So we'd like to talk a little bit about what life is like in panther den and show you how we've learned it using trail cameras. And all this work has been made possible thanks to Deborah Jansen and her panther capture team, all the folks here at Big Cypress. Without them, we wouldn't have any of this. Previously, the only real information we had about what happens in panther den was when the female was there and we could monitor the telemetry data. So we either had our biologist in the box keep track of it or the routine telemetry sites. That gave us very limited data, and it got worse when we started going to duty cycle collars. Whenever you duty cycle your collar, the battery lasts longer, so you don't have to change it as often. So it's a good thing to tell the collar to turn off at night. But the problem is, when you do that, you don't learn anything in the mothers at the den at night. We started with this data. That's interesting color. I'm not sure you got that. The other problem with the telemetry data is it's not really very accurate. This is a den we went out to. The den's over here. Our biologist in the box is over here. We went out there thinking we're going to go over here and triangulate the den and know exactly where it is. Because the biologist in the box said Mom was home. Well, we got there, and it turns out Mama was over here eating a deer. So, as far as you can tell from telemetry data, she was home, but she wasn't really home. So that's why we learned more, or at least more specific data with the cameras. Well, we first started trying to put cameras in the den, and we put a regular Nikon camera in, and it gave us this one really nice picture. And that was it. That's all we got. And then we tried it on another den and didn't get anything. So we had to rethink what we were doing, because that wasn't going to work. So the technical challenges of doing this is you're in a very confined space. Most panther dens are less than 6 feet in any open direction. I measured it because I had to set the cameras up, so we started checking that. It's very low light levels. It's usually under a heavy brush, so you have a hard time taking the picture. And most of the activity is at night. Okay. So the requirements for a camera, probably the most important requirement for the camera, and the only one that you can't compromise on, is you had to have something that won't disturb the panthers. And still had to work at night. So we couldn't really do anything at night until we got cameras with infrared flashes that we can't see. So that was one of our major limiting factors. You also need a camera to be waterproof. Once you put it out there, it often has to stay for a month or longer. So you don't want to put something out that's not going to light itself all the way. And you also need something that will run long enough to get the data you want to get. So it's got to have enough memory and enough battery. You'd like the camera to work quickly. If it takes it 5 minutes to wake up, it's not going to do you any good. So you've got to get something that will start working as soon as it detects motion. And again, because of your confined space, you need something with a wide angle view. And also close focus. If you've only got 6 feet, you can see this panther's just about touching the camera while their kittens are nosing underneath. You're just going to have a hard time getting your picture. A lot of all these strange colors up here. Okay, so while we're searching for the right camera, Panther 150 had kittens. She had 4 kittens. We went in, 2 of the kittens were underweight. As we always do, once she moved the den, we went back to see what had happened. And because 2 of them were so poor looking to start with, we expected to find a dead cat. What we found instead was kitten 255. She had this large cut on her head, and she had lost about 40% of her weight. She had been the largest kitten at the den when we first went in. Didn't know what happened to her, but we brought her out, and with the hopes of getting her treated and taking her back to her family. She got her wound repaired. Dr. John Lanier in town was kind enough to take care of her and stitch up her wound. Fortunately, because she had been in his vet's office, the state veterinarians were concerned that it wasn't safe to put her back into the wild. She'd been exposed to who knows what in the office. So because of that, we had to take her to the Lowry Park Zoo. That's terrible. Anyway, Lucy's doing fine. Lucy's that. Well, a little while later, Panther 153 had 3 kittens, and by this time we were ready with some better camera gear. Reconics had come out with their PC90, which, as you can see here, is a camera that will do 10 frames in a burst at about a second apiece. It will do the infrared at night, it will do color during the day. And if you ask the Reconics factory, they'll focus it at a shorter distance so you can actually use it in the hand. 7 days after that, Ned on her routine flight went over and figured out that the den had been moved, and we then go back in and see what was left and get our pictures back. When we got there, we found another kitten left behind. 275 had been left behind. He had lost 30% of his weight. But this time, at least, we had cameras to give us some idea of what had happened in the den. Anyway, 7 hours after we returned the kittens to the den, FP-153 returned, and she stayed at the den for 2.5 hours. You can see this is a time sequence of what went on by placing those 10 frames every second together. You can sort of get an idea of what's happening in the den. I had to get the space bars in with straight down.
Yeah.
So the next 2 days, we didn't get any panthers, but we did have an opossum running through the den. That's a mighty brave opossum. That space bar won't get any place. Okay, on the 3rd day, Mom finally returns. She stays a very short time. She picks up the kitten, which you'll have a hard time seeing, but right there she's got it in her mouth. She walks off. Then we see the other 2 kittens playing for a while. And then 5 hours later, she comes back, grabs another kitten, and leaves. Over the next 4 days, I will hit the space bar again for some reason. You see 275 running around the den. It doesn't look real happy. Ended up bringing him out also. Kept him for 2 days. He cooked his bottle fairly well. He was very hungry by that point. And his space bar, please. And then 2 days later, we were able to put him back to the den site. I haven't seen him since, so I can't tell you what happened to him. We're hoping he's still out there, though we have no way to know. Well, that was certainly helpful, but it would have been a whole lot nicer to have real video and sound to go with it. And, a little over a year ago, Stealth Pro came out with their Stealth Cam Prowler HD, which gives us at least low high resolution video. And we started putting that out instead of the other cameras. It has the same infrared light that you can't really see, so we can follow the cats. I think space bar, please. So what we've got 151 and her 2 kittens. I find it interesting, they nurse sometimes laying down, but more often they'll be sitting up or standing. I don't know why anybody has the ideas on that. See, the camera's not bad. The range could be a little better, so we don't get quite so much low-down highlights. The temperature is not accurate. It was a hot day. It's the middle of the day. I'm sure it was 95 degrees, but it wasn't 102. But the camera seems to register a little high when you see sunshine.
Is that a recent burn area, or it looks kind of brown and black?
It's still blackened, but it had been many years since it was burned. It was a pretty dense palmetto hill.
Did you hear her make any noises?
No. Did you hear the kittens?
Yeah.
I've never heard her make any noises. These guys are about 3 weeks old. starting to get around fairly well. The next morning, Mom decided it's time to move to den. Unfortunately, she counts better than the other two moms I showed you. 10 minutes later, she did come back for the other one. After they left, most of the opossums come in. Or just to show you the cameras do work at night, but we didn't have any panther pictures at night. Okay, so we'll talk a little bit about cameras. The camera you're just watching, it's got adequate video. They could improve that. Certainly would be nice if it was a little better. The audio's not bad. It could be a little louder, but that's okay. One major problem with this camera is its trigger delay is 4 to 6 seconds. In the den, that doesn't matter too much because they're there, but if you're trying to use it for a trail camera, you'll miss an awful lot or you'll just get the tail of the camera. The maximum video length at one time is 5 minutes. I think that's great. I'd really like to be able to make that longer or have the camera re-trigger every time something moves, but that's actually exceptional. Most trail cameras won't go within a minute. This one, unfortunately, has a 1 minute rest period, so it'll give you your 5 minutes of video, and then it's going to go to sleep for a minute before it'll do it again. So again, then you kind of miss stuff with that. Memory and battery are adequate. I've never had one die before it came to sleep, so that was okay. Current price, they're now down to about $150. You can't hardly beat that for a camera put out of woods. In hopes of finding something that worked a little better, I started testing out some new Bushnell cameras. Again, the video quality is adequate. Probably not quite as good as the Stealth Pro at night, but it's good enough. Got a much better trigger time. They advertise it as 1 second, but I think it's probably closer to 2. The main drawback is it's only will record for 1 minute. So if you're trying to do something like a den where there's ongoing activity, you're going to have breaks in the video. The good news is it only has, the company claims a 1 second rest period. Again, it's probably more like 2. This camera comes in 2 models. The one at the same resolution as the Stealth Pro or a full high definition model. Price difference is not much. The downside if you get the full high definition camera is the angle of view is much narrower. So when you're doing a trail camera, you don't know exactly where you're going to point it, so you'd like to cover as much area as you can. So you get some fairly nice daytime video with it, but you got to have it in the right place. Yeah, that's
okay. So Roy, he received funding for this project for a total of 2 years, and we're a little over a year into the project right now. We started the studying the cameras out in October of 2010, and our study area is this part of the Adlands, the Adlands North, and it's about 70,000 acres total, and we've had up to 35 trail cameras set up in that area over the course of the last year. The objectives of our study are to determine if the panther population can be counted in the study area using camera traps. And we also want to compare the results from the camera trap study to the current method of determining panther population numbers. In addition, we want to increase the number of panther images generated per camera trap visit, and we accomplish this, as Roy said, by using the scent lure at sites along known panther travel routes, where Roy has repeatedly seen sign of panthers over his 30 years of experience tracking in the area. By increasing the number of images generated per camera trap visit, we are, as Roy showed us, more often able to determine the panther's gender. We can see if the panther is wearing a gray collar, and we are often able to see unique anomalies that allow us to identify individual panthers. First, I'll talk about the anomalies. I'd like to introduce you to my big friend Vincent. I've named him that because he has this big chunk kicking out of his ear. the famous artist Vincent Van Gogh. This is a great anomaly for identification because it's very distinct and it's permanent. Here you can see him again. Obviously, we got Vincent. This next slide shows panther. At first, we don't know who it is or even whether it's a male or a female. And that's our scent station up there. And as the panther moves in, Jim, could you verify? Okay. So, you find out that it's a male. And then as he moves in further, moves in to make a urine marker. Oh, turns his head. Oh, there he is. We know it's Vincent. So you can see it's very useful to have this scent order there. Get him to stay around, you can move around where you can see these different anomalies. Here is Vincent again with this little wound on his chest. I know it's Vincent because later in the series of pictures we see the ear notch. It's not a long-term anomaly, but it's certainly something that we can use, for a short period of time to say that that's Vincent, especially in a situation where we may not see the ear notch. Oh, okay. This guy, I was very concerned for Vincent when I saw this panther. This guy, look at him. He's big, muscular. He looks just downright nasty. And he's got this scar over his left eye, so nickname Scarface. Here he is again. He's moved even further into my dear Vincent's turf. And you can see again the scars. Even further into Vincent's turf, again the scars. But then when I went back and looked at this picture, like, hey, wait a minute. That guy, Scarface, he's got the same scar as Vincent. Wait a minute. Vincent's Scarface and Scarface is Vincent. Look at that. So, a really important lesson here was I initially thought they were two different males. But in actuality, they were one and the same. It was my first lesson in how easy it is to overcome these guys. This guy I call Jay. Not very original, I realize, but there's the Jay, you can tell. He does not have the notch in here. You look at him side by side with Vincent, obviously very clear. And when he leaves the scene, see how he's got this goofy looking Jay in his tail. Unlike Vincent, when he leaves the scene, his tail is long straight. This is another male we see occasionally in the edition, and he has a little ear notch here, different from Vincent's on top of his ear. He also has a collar. This makes it really easy to identify this guy. Here he is again, the notch, collar, and then notch, collar. All right, this is a female panther. It actually looks like it's the same picture, but it's actually, 5 days apart? She's got this wound on her hip. Again, something that we can use short term to identify her or distinguish her from other females in the study area. So in addition to anomalies, the natural anomalies, we have an introduced anomaly which allows us to identify individual cancers, and that is a radio collar. We've got this guy. This is Deb and Dennis. I think they know who this is. This is Florida Panther 163. He was collared, or should I say recollared, on November 10th, I believe, of 2010. He actually was initially collared in the Turner River unit, and both Deb and Dennis were there for that. He was collared in the Turner River unit, I believe, in February of 2008. And shortly thereafter lost his radio collar. So this was the first time he's been captured again since that capture. This is male panther 177, also seen in our study area. comparison, because whoever put collars on it, I want to thank you for this, because the collars are the same, but one's on one way and one's on the other. So 177 bolts are on this side, and 163, he's got his bolts on the other side. So great. Thank you. This is female panther, 1 in 4, and this is female 175. And at this point in time, their coverage do not overlap, but if they ever did, you would be able to distinguish them by their different types of radio collars. Okay, so what have we determined so far? From October 20th to 2010, October 20th, 2010 to September 20th, 2011, we have captured 597 panther visits on our 35 cameras. Anytime a panther triggers the camera, we consider this a visit. And the number of images generated per visit has ranged from 1 image to as many as 820 images. I'm not going to show you all those, by the way. So of the 597 visits, 388 were by males, or 65%. 168 visits, or 28%, were by females. And 41 were visits unknown gender, which is just 7% of the total. So that's a pretty good low percentage there. Just a note here on the high percentage of male visits, this is no way an indicator that there's twice as many males out there as females. It's simply a reflection of the fact that the males are on the move more and are moving over larger areas than the females. So obviously they're going to be moving past more of our trail cameras, getting the pictures taken a lot. Now, if you look specifically at the male visits, here's the breakdown. Of the 388 male visits, 216 of those were visits. That's over half of the male visits. We've got our other known males, JTL, 163 and 177, and the notch collar guy. And those 5 guys comprise a total of 89% of the total male panther visits. The other 11% are we were unable to identify. So what conclusions have we been able to draw from the male panthers in the study area? 5 known male panthers have used the study area as part of their home range during the past year. And here they are. We also know that Vincent is photographed often at many camera sites because his home range includes a large part of the study area. Over the year, he's been seen throughout the study area, except for the very westernmost section, and he's been photographed at 158, 135 of our camera sites. The other known male panthers are photographed at fewer sites and penetrate the study area to a lesser degree. For example, that guy Notch, he very occasionally comes up into the southwestern section of the study area. And Jason, he's only seen in the southeastern section of the study area. The third point, and I really want to emphasize this, is that all 5 males were not present in the study area at the same time. For example, I mentioned before, or maybe I didn't mention, I'll mention it now. 163, he was originally, after he got his radio collar, he was photographed mostly in the northwest section of the preserve area that we're working in. And he gradually, after the first of the year, he started moving further and further out of the study area until eventually we didn't see him at all on the cameras. And then his radio telemetry data indicated that he's now moved northeast of the Henry prison. So after he moved out of that portion of the study area, 177 kind of came over from the west and gradually started to fill in that area that 163 had been. Also, we know that the telemetry data for the radio-collared male panthers indicates that their home ranges extend beyond boundaries of our study area, and we would expect that the other known uncollared male home ranges extend beyond our study area as well. Okay, now looking at the breakdown of female panthers. Of 166 visits, 83 were from our two collared females, 184 and 175. And the other 83 were from uncollared female panthers. So even 50-50 split. The big question is, how many female panthers were responsible for the 83 uncollared female visits? And the answer is, well, it's problematic because panthers, female panthers, have few, if any, anomalies which allow for identification of individuals. So here we have two pictures of females from two separate visits. Absolutely no neurotoxicity one, no colics, there's nothing there that we can definitely use to say that's one cat or another. So we really just don't know. We're not sure if it's the same cat. The other thing that makes counting these females problematic of these drug parents is that female panthers that have kittens are not always traveling with them. This is 184. She had 4 kittens in April, and we believe 3 survived because to date we have seen her traveling with at most 3 kittens. But sometimes she's with only 1, and sometimes she's with 2, and sometimes she's totally alone. Here she is. This is October 20th, just a few weeks ago. And there's 1 kitten. You can see the second one in the background. This is 175 and her kittens. She actually had 2 kittens in January, but over several months, we actually never saw her with 2 kittens. We've only ever seen her with 1, so we assume at this point that only 1 survived. And like 184, we often see 175 traveling without her kitten. This chart shows that for both 184 and 175, they are seen traveling without their kittens more than half of the time. This surprised me. I don't know if it surprised anybody else. But, for 184, she is alone 14 of the 26 camera visits. Now this is since we started seeing her traveling with her kittens. So 14 of the 26 visits, which is over half the time, 54% of the time, she is traveling alone. And then with 175, 10 of 16 visits, she's traveling without her kittens, which is 62% of the time. So, what does this information tell us about uncollared females with kittens? Well, I think we can expect that, like collared females, they too would be traveling without their kittens over 50% of the time, and we would therefore expect them to be photographed over 50% of the time without their kittens. So the big problem here is, how do we know if that uncollared female that we saw last week, traveling alone, how do we know if that is or is not the same female that we saw this week, draw a collar, with kittens? We don't. We just don't know because they don't have these anomalies that we can use to distinguish them from one another. And this also is one way that they can be overcounted. Because you could easily say, oh, well, that uncollared female there is alone with 1 panther, and that uncollared female over there with those 2 kittens is a different panther, when in actuality they might be one and the same cat. So, and again, this is sort of preliminary results from our study. We still have another year to go. What we know for sure is we've got our 2 collared females. We have 184 and we have 175. And we know we have these are 2 different uncollared females with 2 kittens each. And we know that because of the age of the kittens. And as I said before, we know that 50% of our camera visits are from 2 collared females, and 50% of the visits are from uncollared females. So if there are a lot more uncollared females using the study area than collared females, then we would think that the percentage of camera visits by uncollared females would be a lot higher than the percentage of visits from the collared females. But still, none of this fully answers that question, how many uncollared females are responsible for these camera visits. One thing we're looking into is using marked recite models to estimate their numbers. Basic premise behind the marked recite is that some individuals in the population are marked. And then encounter data is collected during subsequent sampling periods on both marked and unmarked individuals. And then that encounter data is analyzed in this very complicated mark-reset model to come up with an estimate of abundance. This methodology seems promising, especially if we could mark a few more of our females in the study area. While we feel like we made a good start at estimating the number of male panthers that are using the study area, we still realize that there's some problems determining the number of uncollared females in the study area. So over the next year, we hope to improve on our techniques and explore other options for analyzing the camera truck data to come up with a better estimate. And that's it. And if you have any questions, I'd love to talk about this stuff. We could go on for hours. So if you have any questions, don't hesitate to come up and see me after this session.
Last speaker, Dave, are you here? There was some concern that he'd be left out in the field today.
No.
But I'm very grateful that he was willing to come talk to us today. And he's with the Florida Game and Vertebrate Field Commission.
Almost right. Florida Fish and Wildlife.
Florida Fish and Wildlife. Oh my! It's the game and fish for me. Where's the
Okay, well after those presentations, I'm going to try not to lull you to sleep here talking about genetics. There's a lot of interesting stuff in the last two talks, so probably not the best talk for the last talk of the day, but initially we were planning on doing our capture work this week and kind of got pushed aside by the weather, so all the rain we had. I'm going to be talking to you today about the Genetic Restoration Project. Many people in the room are probably at least somewhat familiar with that project that was implemented in 1995, but hopefully today I'll give you some more information on that project and give you the results of that project and how it's really had a great benefit to panther conservation. I have to start out by acknowledging the multitude of agencies and personnel, and if I forgot anybody on this, I apologize, but any project that's been ongoing for 30 years is obviously going to require the help of a lot of different people. So recognize those people here and the agencies, but most importantly, I want to recognize the citizens of Florida that support our research at FWC on panthers. All of our work at FWC on panthers is supported by those CAT tags, the Florida Panther tags you see out on the road. We don't use any general revenue or tax dollars for our research, and that's a real bonus, and we're really lucky to have that program. So I'd like to thank authorities for that support. I guess there wasn't as much background information in the previous talks on panthers, so I'll give a little bit of it here. I won't play it too long because I think a lot of people are familiar with the different aspects of Puma concolor, which is the scientific name for pumas, cougars, mountain lions, panthers, different names, different locations. You can see here Idaho, Florida, Wyoming, that's Texas. So they're a cat of many names, and they're widely distributed throughout the Western Hemisphere, from almost up in the Yukon down to the tip of South America. And they were once widely distributed across the eastern United States, but they've been extirpated from that part of the range, and today there's only one breeding population of pumas remaining in the eastern United States, east of the Mississippi River, and that's the Florida panther. And that's going to be the critter that I'm going to focus on today, and then talk to you about the genetic restoration project of this endangered population of panthers. I want to start off with kind of like a little bit of historic background on the distribution of pumas in North America. You can see, just kind of keep these cats in the back of your mind as the talk progresses, but the Florida panthers range right here. This is a map from Young and Gold in 1946. Notice how it abuts to subspecies number 12, which is Puma concolor stanleyana. That's the Texas puma. That'll come into play here in a little bit. Looking a little bit closer at the range of Florida panthers, you can see historically they range from western Louisiana all the way through the southeast. and through the entirety of Florida. But due to a variety of factors, mainly unregulated hunting, killing, and the loss of habitat, they've been subsequently isolated down into the tip of Florida here where they persist today. Panther numbers declined throughout the 19th and 20th centuries to the point that many people thought that they were extinct. There were some measures taken initially by state government and eventually the federal government to try to conserve the panthers. Most importantly, in 1973, the Endangered Species Act protected Florida panthers. During this time period, like I said, the panthers were very rare, very rarely observed in the wild. There were some, what I call semi-cryptic releases that were attempted, especially in the 1950s. These are captive animals that were released in the wild. The process wasn't very well documented. The lineages of these animals were suspect, even though they were thought to be, by the owners, pure panthers. Subsequently, our genetic analyses, as you'll see, will show that some of these animals obviously were not pure Florida panthers. The one of note is the Everglades Wonder Gardens cats that were released in Everglades National Park. So during the early 1970s, Roy and Nowak did a survey in Florida to try to see if, what's that? Yeah, I think it is. I think it's Deb and Walt and Jade. So in the early 1970s, Roy and Nowak did a survey to see if panthers still did exist in Florida, and they were able to